Hello, everyone. Can you hear me?
Yeah, we hear
Cool.
you.
Perfect. Thanks a lot for having me. We'll be talking about Python and machine learning. Surprise. Okay. So my goal is to speak about machine learning and Python from the point of view of a developer. Quick introduction. So my name is Laurent Picard. As you can guess, maybe from my accent, I am French. I am currently speaking from Paris, France, and I'm a developer advocate working with Google Cloud for 4 years almost now. And in a previous life before that, I worked as an ebook pioneer. That was 20 years ago. I worked for 17 years in the ebook industry. So yeah, in 20 years ago, we made one of the first ebook devices in the world. And for 4 years, I've been focusing on cloud technologies. And among these technologies, machine learning is magical. But I love this quote from Clark because it still represents what I'm feeling like when I see something new developed with machine learning. It's still magical, and it's been a few years that I've been watching applied AI, applied machine learning. But this is just technology, and my goal today in this presentation is to show you that as a developer, you can do something magical. You can use machine learning. Okay, I'll try to give you a big overview. So what's machine learning? This is my own definition. This is how I have used machine learning for the last years. You have data as input, and from this data, you extract information. You're able to understand what your data is made of. What is the information that you have in your data? Of course, as you know, this is not the real definition of machine learning. I will pass on this one because if you're here, most probably you know that machine learning is a part of AI. And in particular, deep learning gave us most of the progresses these last years, and it's just the beginning. So how does it work? The experts, and that was 40 years ago, the first researchers, they tried to mimic the way we think our brain works. We still don't know if it's if it's identical or not, but it seems to be very close because we get very close results. We also need many examples. So we need examples to learn from these examples. And if you think about it, it's a little bit like we learn as kids. We do learn from examples, from our parents, from our sisters and brothers, from our friends, from our teachers, from anything that surrounds us. And the magic, anyway, for machine learning is that we are able to solve problems. So we can solve problems that we were not able to solve before with handmade algorithms. So that's the magic for me. And as I said, it's just the beginning. Maybe the only issue is that we don't always know why we managed to do the magic to solve the problem. But this is a big field, explainability, that researchers are working on right now. So why is it possible? One might say because it's been at least 40 years ago that researchers worked on this field. So first of all, we have a lot of mathematical, physical theory, even biological data, big data. We've been able for 20 years now to store big data on hard drives and so on. So big amounts of data. And for, let's say, 10 years now, we have access to very high computing power, and especially thanks to cloud technologies. Of course, we have very powerful laptops, computer servers that we can have on-premise. But the advances that we see for the last years is when you're able to do that in the cloud, to train a model in the cloud and do it in hours instead of days or weeks. Okay. So let's take a step back and see how we can benefit from machine learning as a developer. If you can develop expertise, and in this case, you will deal with neural networks, right? But that is very time consuming. You need to invest time. You need somehow to specialize in some fields. You cannot know all about machine learning. It's so big now. If you spend most of your time developing solutions, then there are already pre-trained machine learning models available to you. They are available as machine learning APIs in different forms. And another big field that has been developing for the last years very quickly, and it's very, very promising, and it's filling a big gap, it's AutoML techniques. And with AutoML, you can actually build your own custom models, still without having any expertise in machine learning. So if you keep this schema in your mind, it means that in your company, if you're an expert, or if you're working with experts, maybe they can focus on innovation, because now specialists, this is where they can provide added value. They can build something great and invent something, bring innovation. But as a developer, or sometimes you don't even need to be a developer to build a data set, then you can focus on developing state-of-the-art solutions that are very smart and that will use one of these two machine learning principles, existing models, or a model that you can build yourself without any expertise, because this is a known problem, a problem that has been solved, that AutoML can automatically solve for you, build the best model for you. Okay. So let's have a look at this. Internally we call that the building blocks. So you see like these Lego bricks. It's because you can take any of these bricks and integrate it into your solution to have something smarter. Okay. So let's have a look at the machine learning APIs. Of course, I will illustrate that with something that I have access to, so the Google Cloud machine learning APIs. But keep in mind that I'm showing mainly principles, and if you're already working with another cloud providers, or maybe if you want to have a look at some specialized companies, the principles in general stay the same, and you will find many of the features and the examples that I show you right now. Most of the time they are available elsewhere. I will tell you when there's something unique. And so if you remember my definition, you have data as input. So data can be, in our case here, text, images, videos, or even speech. And from your data, you extract information. You understand what you have in your data. Or sometimes the data you want, the information, is actually your input that has been transformed into something else, something intelligible that you can use. Okay? So I always start with the vision model, the R Vision API, because for personal reasons, in the 90s, this is when I was learning computer science. I was a student, and at the time we were trying to solve this problem. We were trying to recognize and detect objects in pictures. And at the time, what we could do, and my teachers were also researchers, is that we would use convolution filters, and we would try to detect edges in pictures. So it's the difference of contrast mainly that you can see, and from the edges detect maybe that those are flowers, maybe it's a door or a window, we don't know. There are some bricks here it's weird, maybe clouds, so that we managed to do something. But as soon as we would use new pictures, it just failed miserably. So this is where magically machine learning is able to solve this problem very nicely. Somehow machine learning is already doing that. Edge detection is embedded. Machine learning is doing convolution filtering on pictures, but it's doing a lot more. It's able to understand, detect textures and maybe groups and so on and so on. And there are different layers. Okay, and this is why it works. So let me show you examples of what a vision model can do. If you give a picture to a vision model, first, of course, it's able to describe it to you with labels. And here what I get is, okay, these pictures about nature, flower, and so on. And I have a confidence level here, 95%. Everything's correct. Here, this is the kind of response that you can get from the API. So you see, you have this JSON stream is a list of labels, nature, with an identifier and a score here. This is the 95% that you have here. Okay, but more precisely, and this is something that amazed me. A machine learning, a vision model is able to match pictures, pictures that are different. And so this is the same pictures as before, but I changed it quite dramatically. I flipped it, I zoomed in, I cropped it, I applied a color filter on it. So it's very, very different. It's not even the same ratio. The pixels are a lot bigger. And still, the vision model is able to match this picture with another one that is actually the source that I got from the web, and tell me from the environment, from the context of the picture, tells me that most probably this picture has been taken in New Zealand, and I even have the GPS location of Hobbiton, and this is really where the picture has been taken. This is the set of the movies, the Lord of the Rings trilogy. So, of course, it's not cheating. It's not using the GPS location that can be found in pictures. Can use it if you ask it for, but by default, it's just guessing and tells you what this picture looks like, or if it's close to another one. More precisely, a vision model is able, and that's more recent, is able to detect entities, persons in a picture and give you a precise location. And here, so that's the movie cast that I think went to the restaurant. And what I get here is bounding boxes for the different persons, but more even a person in the background here. But more precisely, I have here a bounding box for pants, for tops, and even here for a ceiling lamp. And even more precisely, if there are faces, then you can know now. So here it's a 3D rendition of Gollum. Not really a human face, but let's say it looks like a human face. It's able to tell me that this is a face. It even gives me the cropping box. So if I want to zoom in and have a close-up of the face, I should use maybe this box or even closer this box. And I have the precise locations of the mouth, the nose, the eyes, and everything. And more than that, I can have a sense of generic emotions. So sentiment detection is done here. And what the vision model tells me is that likely this face is angry. You see the big score here. And that's Gollum. And yes, Gollum is always angry. And I have a lot more features like the position in 3D of the head and also the depth of the different features, face features that have been found, and even more. Another problem that was hand solved before, and that's nicely solved now, fully solved thanks to machine learning, OCR, optical character recognition, text detection. So here, this is a screenshot. And what I get from a vision model, I get all the different levels, so the different blocks of text, the different sentences, the different words, even the different symbols. That is near perfection. It doesn't make mistakes on this kind of screenshots. So it's also interesting to see the limit of models, because as humans, as machine learning models work a little bit like human brains, or we think so, they can make mistakes. And so I always try to see the limits here. If I apply a perspective effect to the screenshot, it still works nicely. Maybe the only difference that it does is here, the double quote at the end becomes a single quote. So no big deal. It's still an almost perfect transcription. So I said we can consider that OCR is a solved problem. But the next step, and it's also almost solved problem, is handwriting detection. It works very well. It's makes a little bit more mistakes. But here, this is a sheet of paper with Tolkien's handwriting, with his famous quote. And here, maybe the only annoying mistake is here, shadows. So there's no syntactic analysis. It's just based on our OCR and writing detection. So here I have a V instead of a W. And a small mistake here is that the bottom of the F letter becomes a single quote here. But everything else is great. If I want to be picky, I would prefer this to be a single block of text to be detected, but everything else is just great. That's perfect. And also a cool feature of machine learning models is that they improve with time. As they're learning from samples, the people who train machine learning models just have to give more examples, better examples, counter examples, and machine learning model improve with time. And I have the proof with this because last year I tried the exact same example, and it was making two more mistakes. As of today, it's making two less mistakes, and maybe in a few months it won't do this mistake anymore. So that's also a very super cool feature of machine learning models. And finally, with a vision model, also, you can try to detect web entities. So web entities are persons or objects that are famous. And here, to illustrate that, I took a very rare picture. I found a very rare picture of Tolkien that has been used only once in a Spanish newspaper. It happens that the article is online, but just once. And to really try to trick the system, I also, once again, zoomed into the picture, cropped it, and applied a color filter. So it's derived from this unique picture, but it's a very different picture, and especially for a machine. And still, the vision model is able to tell me that there's a partial match with my original picture. And what's amazed me is that from the context of the article on the web, it tells me that most likely this picture is about Tolkien. Okay. And what I get also that's great for a developer is that I get a unique identifier here, a unique ID that I can use to uniquely identify Tolkien wherever. So this ID comes from our knowledge graph. As you know, we've been crawling the web for 20 years now, and so this comes from there. This is the knowledge graph ID for Tolkien the father. Of course, if it was Christopher Tolkien, his son, then it would be a different ID, and it means we can use identifiers and not just deal with text that can vary sometimes. Okay. So I told you it's an API. So this is an interface that you can call. You can do a web request if you want, but of course it's a lot easier to use your favorite language, and Python it is, right? And so those are wrappers around the APIs that are open source. And here this is the Google Cloud Vision package that you can install. And it's always the same principle because it's a wrapper around an API. You create a client, you define your input. So here that's an image, and then you call the feature that you want. So for instance, face detection. And for a picture, it's almost real time. And then you can use the result right away. You know where the faces are. You know whether faces are surprised or sad and so on. Okay. And you see just this few lines are enough to identify faces and know where they are located into the picture. We will do a live demo altogether a bit later in the middle of the presentation. Okay, in the second part. Okay, let's move on. You can extrapolate what you've seen on pictures with videos. Videos are like pictures, but with one more dimension, right? Time. And So I will go pretty fast. I will just show you a demo altogether. If you're able to understand what you have in your video, it means you can index it. And so here, so this is an example of this demo, where if you input videos to the model, you will have annotation. So you will have different labels. But as it's a video with time dimension, then you have the different sequences, you see. So I know that here there's a skyline and so on. You can, from a video, you can extract text. So from all the everything that has been spoken into the video, you can get the text. And also, if there are entities, then you can know where they are located. So here I have many persons if in this video, but also you can track them. So let me show you an example. I know that there's a horse here. I will zoom in. Okay, let me show you the horse. Okay, and what I found very interesting here is that there's a person, so that's the movie Rebel, I think it's called like that in English. There's a person on a horse. So the person is perfectly detected and the horse too. But actually there's a morphing. There's a morphing from the drawing to the 3D rendition. And you can see that the person is tracked. So maybe you see. Okay. So the horse and the person are being tracked perfectly from the beginning to the end of the sentence. And that's something that I wouldn't know how to do with just algorithms. Okay. So let's, an example in Python of how you can do that. I've written a few tutorials to use these APIs. If you want to have a look maybe at just the Python code, they are available. I forgot to tell you, I will give you the link to my presentation at the end in the chat on Pine tool. So you can focus, you will have everything at the end, okay? And so here on my GitHub and also on Code Labs, there's this tutorial I've written where I detail all the features that you can do. Just here, I'm showing you one. It's object tracking. So always the same principle. You can create a client. You indicate you indicate what you want to do. So here, for instance, object tracking, and you call the feature you want annotate video on your input video. You wait a little bit. This is not real time. Of course, it will depend on the length of the duration of your video. But then at the end, you have all the results that you asked for. And here with object tracking, you can actually know the bounding box of the different objects that have been detected. And so it means you can extract them or index them or whatever. Okay. So we've seen most of what you can do with visual content, right? But at the beginning, everybody worked on text. So now let's speak about text. And that's like OCR, that's also a very big field. It's called NLP. You must know NLP is natural language processing. And so there are natural language machine learning models. And ours is called the Natural Language API, the NL API. And of course, the first feature is you're able to analyze the syntax of the text that you provide. The text can be anything, can be a full chapter, a full book, a full article, can be just a few paragraphs, can be sentences. So let me show you an example on this sentence. So first, the natural language model tells me that it's in English. Okay, no big deal, pretty easy to guess. But it's able to give me the exact syntax of this sentence, a very precise one. And I did work with companies that specialized in natural language processing. They worked with linguists, and they were not able to get this level of precision. Here, what I love is that I have the punctuation analysis. I have all the different relationships between all the items. I can also work with lemmas. Lemmas are the canonical forms of the different. So for instance, was is the verb to be, and I could also get rid of the tenses or the plurals or work with canonical forms. It can be very handy. Another thing, and that's something that you saw on pictures, it's able to detect entities or it's able to label your text, right? And here I have three main groups. In red, I have persons. Tolkien is detected as a person, a writer, a poet, and so on are persons. But what amazed me here is that Tolkien here in this sentence is detected, of course, as Tolkien, but I have the unique ID here for Tolkien, and that's exactly the same ID as before in the picture with Tolkien. So it means I can really deal and recognize a work with entities in text and videos and pictures. Okay. British is recognized as a location. It's mapped to the United Kingdom, which is correct. And the three books here at the end are each detected as works of art, and that's also perfect. Okay. Another very useful feature is content text classification. And so if I ask the natural language model, where should I classify this? It tells me it should be classified under books and literature at 97% of confidence, and that's perfect. This kind of feature is used by, for instance, newspapers. They, especially legacy ones that have been here forever, their first editions were just in paper, right? And they have big amounts of archives that they can scan. And from the OCR, then they can get the text, and from the text, then they can classify their different newspapers and each article individually also. Okay. And finally, like in pictures, you can get a sense of the sentiments that are expressed. Sentiment analysis on text is a score that is between -1 and +1, telling you whether we are speaking negatively or positively about the level of text that you're dealing with. It can be a full paragraph, it can be one sentence, it can be one entity inside the sentence. So to illustrate that, what I did, I chose two different reviews of The Hobbit. A negative one that I found on a social network, and a positive one from the New York Times back in the days when The Hobbit was released. And what I get works really well. I get negative scores for the sentences in Pauline's review. She really hated the book. I get positive scores up to 0.9 for the positive review of the New York Times. And I get, of course, I didn't show you, but I get many, many neutral sentences because most of the time we speak neutrally, right? That is super interesting because some companies are using this kind of feature to know how their users or their customers are feeling about their products, their solutions, their services, or even just the company, the brand, or some products. I know that some are browsing social networks and analyzing everything that is being said about them. And I even know one company that has optimized and improved their customer service because they are parsing all customer emails every day on a daily basis or during the day. But when the customer team starts their day, they deal with negative emails first because negative emails most of the time represent problems, and you want to help the customers that have problems first. A very positive email, maybe it's not worth reading it in the morning. Maybe you can wait a few hours, right? And so what it means is that this team is now a lot more efficient than before. They have improved their customer satisfaction. Okay. Here's an example of how you can use that with a Python package. You create a client, you provide a document, and you call the feature you want. Can be analyze sentiment, and then it's also very, very fast. Then you can know for the different levels. At the level of the document, for instance, you can know whether we're speaking positively, neutrally, or negatively in this corpus. Okay. Then the other part of text and machine learning is translations. So it's also something very, very big. And maybe I will not describe everything because I think all of you have used Google Translate at least once. Okay, so here's an example. The code is not very readable because I have too much comments or logs. There are just 2 lines needed. You create a client and you call translate. But I'd like to share a fun fact with you. So in 2016, I was still working in my ebook company, and I was using Google Translate. And one day I noticed something really weird. I was mainly translating Chinese and Japanese document into French or English. And suddenly the results became very, very good. Because before that, you could tell that it was a machine translation. And one day I thought, oh, the quality is a lot better. Are they doing that manually now? And I know what happened. And actually, there are some public articles in 2006, so about 5 years ago. The Google Translate team switched the model from a mainly statistical model to a purely machine learning model. Of course, there are still statistics embedded in machine learning models somehow, but the machine learning model is the one that brought up the bump in quality, this huge advance. And for 5 years, the team is still monitoring the results. And for 5 years, the machine learning model just kept improving gradually. And so it's almost, so we couldn't say it's human translation quality, but almost. It's very, very good translations that you can get, and in many different languages, over 100. So that's the kind of amazing thing that machine learning can do. And as I said before, it just keeps improving, but maybe you helped improving it. So if you use Google Translate on the web, there's I think a small box where you can indicate that the translation that you get is not good. When you do that, somehow you indicate you are not giving a counter example, but you are giving an indication that the result is not good. And so this is useful to train and improve the model. And even better, some users can provide a better translation. And so it will help at the next iteration to train the translation model and get a better one. So this is why it just keeps improving. And of course, there's also still a lot of research being done to improve everything. Okay. So we've seen everything that is visual and textual, or most of it. Now speech. And speech as for a few years now just became also a solved problem. So the first one is speech, the speech to text model. You can speak and your speech is transcribed into text. That is the first building block for any assistant. Maybe you didn't think about it, but whenever you use your smartphone, I think it's on all smartphones now, whatever the brand or the OS, you can speak to your assistant, and your voice is transcribed into text. The text is analyzed, so 2 building blocks: speech to text and natural language analysis. And then, of course, there's some processing that can be done, maybe by another machine learning model to give you an answer or to understand what you really want to do. One magical feature of the speech of a speech-to-text model is, as it's learning from real life samples, the model is robust to noise because the real samples have noise, right? And so this is why it's working so well, and we don't think about it because it's able to work with a noisy environment. Okay. It's able. The latest features I forgot to tell you. It's able to automatically detect the language. It's able to provide you a transcription with punctuation. Also, that's something that was nobody did before. It was very hard to do. And of course, if you're able to understand what's in your speech, you're able also to index every word and get a timestamp for every word. So it means you can maybe do a search engine and browse among your dozens or hundreds of hours of speech that maybe you have in your archives. Okay. So this is another tutorial that I wrote, how to parse an audio file and extract the speech and transcribe it into text. So I recorded myself with a French piece of poetry by La Fontaine, Maître Corbeau sur un arbre perché tenait en son bec informal. It's a very famous French piece of poetry. And I tried it. And so I said, okay, this is French, so I think it's not necessary now, but this is or this is to help or get the model to work faster. I asked for automatic punctuation, and so that's really nice to have punctuation in your transcription and for timestamp for all the different words. And what I get is this. This is exactly what I pronounced. I have an uppercase at the beginning. I have a dot at the end of the sentence, and I have a high level of confidence. And that's really, really great. And this is why assistants work so well. Maybe you have also an assistant a hardware device nearby. It's the same technology. Okay. Now the opposite, text to speech. And I did work with text-to-speech engines in the past. If you remember, I told you that 20 years ago I made one of the first ebook devices. I was very proud because I embedded a text-to-speech engine 20 years ago in this ebook device. I worked for 3 weeks. We launched the firmware update, and then we waited for the results. And people just didn't use it because 20 years ago it was a robot speaking the book aloud to you. It was like Alice in Wonderland and so on. It was really painful. So you just tried it for 30 seconds. Now speech generated, synthesized speech generated by machine learning models is very, very natural. And ours is called WaveNet. So the WaveNet voices, the WaveNet technology, they are research papers if you're interested. And it's been developed by Deepmind. Maybe you know them because they've beaten the world champion for the game of Go. More recently, they have beaten gamers at StarCraft, and they are very good at starting from scratch and building machine learning model to solve very specific problems. So two cool features with this model is that the voice is really, really like a human voice. It's very hard to tell the difference. And also it's doing better than real time because in 1 second, you can generate 20 seconds of speech. Okay. I'm going to show you a quick demo. Maybe you didn't notice, but you can do a search in your browser. So let's go to the English page. Okay. Okay, I go to the English one, and you see here you can do a search with your voice. So I'm going to use my microphone and pronounce something in English. Could be in French, but I'm doing it in English for you, but with my French accent. Okay, and let's see what happens. What is the temperature in Paris? And I'm hearing the answer. So I don't know if you could see with the frame rate, but I got results in real time. And as soon as I started to pronounce, I got another word, but the final result is just perfect. So it means that it's real time. So maybe you can go a lot faster and prefetch some results and so on and so on. But here, what I want to show you is the way I pronounce it with my French accent, maybe an English person wouldn't understand it. And here it got me. It understood everything. So somehow, and if I do the opposite, if I pronounce a French sentence with a British or with an American accent, or whatever alien accent from outer space, it works. It's able to understand me and transcribe my weird sentence that some people wouldn't understand into what I have pronounced. Another amazing problem that is solved thanks to machine learning. Okay, so here this is a tutorial that I've written, and just to show you that with just these few lines, you can generate WAV files pronouncing these sentences with different accents. The Australian English, British English, Indian English. Of course, there's the American English, but it also works in I think it's 42 different languages right now. So there's the French, the Canadian French, and German, Italian, Spanish, many more. Okay. So we've seen what you can do with existing machine learning models. Now let's see what you can do when you're stuck and still without any expertise. And this is when AutoML techniques can help you. So let's imagine I want to build something I want to detect the shape of clouds to build a weather forecast application. If I use these features with the vision model, I will get the same results, because basically those are clouds in a sky, right? So it's almost, it's basically the same results. So I'm stuck. What if I want to detect cirruses here and altocumuluses here, right? Then I can use AutoML. And for AutoML, I need to work a little bit more. It's not ready to use. You need to build your own private data set. You need to provide examples, samples. And here in this case, that would be examples of cloud pictures, right? And then everything else is automated. You can launch a training and it will be the state of the art, the best model available to you. You have two options. Either you want the best possible accuracy, and so you will ask for a cloud model, and the cloud model will be available as with a REST API, so you can do live detection prediction, and your API will be automatically served. Or maybe you just want to do batch processing on different files. And in this case, you don't need to serve the API. It will automatically be served just for the time of your batch processing. But what if you want a model to run elsewhere? And in this case, you will not train a cloud model, but you will train an edge model. And an edge model is a model that you can export and get to run elsewhere. So first of all, you can export it into the TensorFlow save model format, and it means that you can get it it can run in a container. So it can run on a Raspberry Pi, for instance, with a Docker layer. You can export the model in the TensorFlow Lite format, and it means you can embed it in a mobile application. And what amazed me more recently is that you can even export it in a TensorFlow JS model. So it means it can run in a web page, and actually did a small project with that. And once you have the model where you want it to run, it can run in real time and offline. Okay, so let me go on with the cloud example. You need to provide pictures. This is image classification in this problem. You need to give a label to each picture. So you see, you don't need thousands of pictures. Here, 100, 200 on average per label, and you get very good results. And then you launch a training. It's an iterative process often, because the first time you make mistakes in your data set. Every time I've done the data set, I've made mistakes. So I launch a quick training. I realize that I have mistakes in my data set. I fix them, and then I launch a longer training. And here on my second iteration, I reach 90% of precision for my model, which is very good, just with this small data set. Okay, one of the tools that can help you for this kind of problem is the confusion matrix. And here I can see that It's very good for 4 of the 5 clouds, but it's bad because it's misguessing for, let's say, 50% of the time. It's misguessing the altocumulus. So here I have an indication that my data set is not maybe diverse enough. Maybe it's biased. So first of all, I don't have as many altocumulus features as everything else. And even worse, they very much look like the same. So building data set is a kind of art, or will become an art, because you have to keep that into your mind. You need to have a balanced data set, and you have to try to remove bias. But here I know exactly what I have to do. I have to remove some altocumulus features and provide different ones, better ones. Okay. And then once my model is trained, I'm happy with it. I can use it. This is a picture I took in Poland on my smartphone. The model has never seen it, never tested it, never trained on it, of course. And it's able to tell me that there's a cumulus in there at 97%, and that is perfect. Okay. So I showed you what you can do on pictures, but it works, of course, also on videos and text and even structured data. We could spend hours speaking about it. Here are the few features that you can use on videos. For instance, you can do custom object detection and tracking inside videos. Here, the problem we saw is custom classification, but you can also do custom object detection on pictures and videos, and so on and so on. You can do your own custom translation. You can detect custom entities into your maybe more business-oriented corpuses of text. Okay. So all the AutoML model services are available in the unified AI platform. So this is a screenshot to show you what you can do. For instance, the last project I've done is image object detection, but I very much would like to try this one out. Okay, so it's demo time. So I've done an AutoML model where I used a few pictures of myself, teammates, and other attendees that let me do it, of people with the tongue out, with their sticking their tongue out, people yawning, and people sleeping. And so let's try all together. Okay. I think there's a 20-second delay, so I will give you some time. So you can use this QR code to connect to my demo from your smartphone or from and from your laptop. Sorry, you can enter this short code bit.ly/python4ml, bit.ly/python4ml. Okay, so let's get started. It will ask you for if you're okay to use the camera, and you can try to trigger. So this is using the vision model, the first part. You can try to trigger any of these emotions. Okay, so my selfie is uploaded, so it's going fast, and it does recognize at over 80% that I am surprised. And as I know where my nose is, my mouth is, and the orientation of my eyes, then I can add a mustache to everyone. Okay, so let's do another one. Hey. Okay, you can do likewise. So here I'm joyful, it works. And now let's try my own model. And with my own model, you can stick out your tongue. So feel free to do so, have fun. And so it works, yeah. So I clicked that to be able to use my pictures again. And maybe let's try another one. So in AutoML mode, you will have a mustache with the colors of the French flag. And let's try to yawn. Okay, uploaded, I'm yawning, it works. So you could say that I'm cheating because, of course, the model used pictures of me, of myself. But let's see what we have with you. So here, the two of us are surprised. Nobody sad, nobody angry. I did stick out my tongue here. I did yawn. And we have two attendees who got to sleep. One more. Okay, so you see it works. I'm sorry, I'm rushing a little bit, so maybe some of you couldn't see the URL. And if you remember, we're also able to detect entities. And so here I'm showing you all the attendees who have glasses, okay, and mustaches now, okay? So you see that is very easy to do. So this is the architecture of the demo if you're interested. I'll pass on this one. This is just to remind you that there are 4 cases, 2 types of good results and 2 types of mistakes. If you want to focus on precision, then you want to minimize the number of false positives. Precision is like a metric for the quality of your model, but maybe you prefer quantity, and in this case, you will use the recall metric, and the recall metric relates to the false negatives, and in this case, you're trying to minimize them. And so the recall represents the quantity of results that you'll get. Especially if you're doing a search engine based on the machine learning model, you will focus on the recall. And to arbitrate between precision and recall, that is the threshold, the confidence level that you'll use. And the lower it will get, maybe the more you will focus on recall, on quantity, okay? Under the hood of AutoML, there are 3 main techniques. The first one maybe is unique to Google is there are research papers. It's called a neural architecture search. So before launching the actual training, we are first launching other trainings. We are evaluating with dedicated hardware that we built. It's called TPUs, Tensor Processing Units. We are evaluating the best architecture for your training. So that it gives the best quality and also the fastest way. Then a technique that is known to experts is transfer learning. From your data, you will have additional layers. This is how. Yes.
Could we run out of time?
So I'm over time, right?
Yeah.
Okay. So I'm wrapping up. If you're interested, you can follow me. This is a project where I'm detecting components on an electronic board in a web page. And just maybe 10 seconds, the ML APIs, there's no difficulty. It's just a matter of hours to use them. With AutoML, you need days. And I needed 2 days to build my AutoML data set and get my demo to work. Okay. Those are examples on my GitHub of how you can build a summary of a video, how you can build animations, or the mustache demo that I just did. Here I'm going to give you the link in the chat. This is a nice comic book about machine learning. And here are my slides if you want to check them later. I want to thank you for having me today. It's almost 1 a.m. in Paris. I hope it gave you a nice overview of what you can do as a developer as of today. And ideally, I hope I gave you a few ideas. Thanks a lot for having me.